ಯೂಟ್ಯೂಬ್ ಇಂದ ನೋಡ್ತಾ ಇದ್ದಾರೆ. ಸೊ ಒಳ್ಳೆ ಪ್ರತಿಕ್ರಿಯೆ ಬರ್ತಾ ಇದೆ. ಗೆಟಿಂಗ್ ಗುಡ್ ರೆಸ್ಪಾನ್ಸಸ್. ಇವತ್ತು ನಮ್ಮ ಜೊತೆ ಇರುವ ಗೆಸ್ಟ್ ಸ್ಪೀಕರ್ ಡಾಕ್ಟರ್ ರಿಚರ್ಡ್ ಗೊನ್ಸಾಲ್ವಿಸ್, ಡೈರೆಕ್ಟರ್ ಆಫ್ ದಿ ಲೋಯೋಲಾ ಸೆಂಟರ್ ಫಾರ್ ರಿಸರ್ಚ್ ಅಂಡ್ ಇನೋವೇಷನ್. ಅವರು ಸೇಂಟ್ ಅಲೋಷಿಯಸ್ ಕಾಲೇಜ್ ಮಂಗಳೂರು, ಅದು ಆಟೋನಮಸ್ ಕಾಲೇಜು, ಅಲ್ಲಿ ಪ್ರೊಫೆಸರ್ ಆಗಿ ಕೆಲಸ ಮಾಡ್ತಿದ್ದಾರೆ. He has got an MSc, an MA, MBA, an MPhil and PhD from different institutions, mostly from the Mangalore University. Published about 27 books, authored 27 research papers, authored and edited 7 books, and guided students of a PhD. More than 35 years of experience, including 12 years of research experience, also awarded from the AISCHE. So with all this, Dr. Gonsalvis ಅವರು ಬಂದಿದ್ದಾರೆ. ಅವರಿಗೆ ನಮ್ಮ ಕೃತಜ್ಞತೆಗಳು ಅಕಾಡೆಮಿ ಕಡೆಯಿಂದ. ಅಂಡ್ ಅವ್ರ ಸೊಲ್ಯೂಷನ್ಸ್ ಬಗ್ಗೆ ಮಾತಾಡ್ತಾರೆ, ದ್ರಾವಣಗಳು ಅದ್ರ ಬಗ್ಗೆ ಮಾತಾಡ್ತಾರೆ ನಮ್ಮ ವಿದ್ಯಾರ್ಥಿಗಳನ್ನ ಉದ್ದೇಶಿಸಿ. ಸೊ ನಮ್ಮೆಲ್ಲರಿಂದ ಮತ್ತೊಮ್ಮೆ ಕೃತಜ್ಞತೆಗಳನ್ನ ಹೇಳ್ತಾ ಸ್ವಾಗತ ಕೋರ್ತಾ, ಡಾಕ್ಟರ್ ರಿಚರ್ಡ್ ಗೊನ್ಸಾಲ್ವಿಸ್ ಅವರೇ, kindly we request you to deliver the topic.
Thank you, Ayappan sir, for your kind introduction. ವಿದ್ಯಾರ್ಥಿಗಳೇ, ನಾವು ನೀಟ್ ಕುರಿತು ಸ್ವಲ್ಪ ಮಾತಾಡಿ ಮತ್ತೆ ಸೊಲ್ಯೂಷನ್ ಎಂಬ ಚಾಪ್ಟರ್ ಅನ್ನು ನಾನು ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ದೇನೆ. ಸ್ವಲ್ಪ ಒಂದು ಅರ್ಧ ಗಂಟೆ ಕಾಲ ಸೊಲ್ಯೂಷನ್ ಚಾಪ್ಟರ್ ಡಿಸ್ಕಸ್ ಮಾಡಿದ ಮೇಲೆ ಕೆಲವು ಕ್ವೆಶ್ಚನ್ಸ್ ಗಳನ್ನು, ನೀಟಲ್ಲಿ ಈವರೆಗೆ ಬಂದ ಕೆಲವು ಕ್ವೆಶ್ಚನ್ಸ್ ಗಳನ್ನು ಡಿಸ್ಕಸ್ ಮಾಡ್ತೇನೆ. ಹಾಗೆ ಲಾಸ್ಟ್ 5 ನಿಮಿಷ ನಿಮ್ಗೆ ಏನಾದ್ರೂ ಕ್ವೆರೀಸ್ ಗಳಿದ್ರೆ, ಕ್ವೆಶ್ಚನ್ಸ್ ಗಳಿದ್ರೆ ನೀವು ಕೇಳಬಹುದು. ನೀಟ್ ವಿಚಾರ ಮಾತಾಡೋದಾದ್ರೆ ಇಲ್ಲಿ 180 ಮಾರ್ಕ್ಸಿನ ಕ್ವೆಶ್ಚನ್ಸ್ ಗಳನ್ನು, ಬಯಾಲಜಿಯಲ್ಲಿ 90 ಕ್ವೆಶ್ಚನ್, ಕೆಮಿಸ್ಟ್ರಿಯಲ್ಲಿ 45, ಫಿಸಿಕ್ಸ್ ಅಲ್ಲಿ 45, 3 ಗಂಟೆಯ ಎಕ್ಸಾಮ್ ಇರ್ತದೆ. ಇದರಲ್ಲಿ ಲಾಸ್ಟ್ ಇಯರ್ ಏನ್ ಮಾಡಿದ್ದಾರೆ ಅಂದ್ರೆ 35 ಕ್ವೆಶ್ಚನ್ಸ್ ಅನ್ನು ಕಂಪಲ್ಸರಿ ಆನ್ಸರ್ ಮಾಡಬೇಕು. ಮತ್ತೆ 15 ಕ್ವೆಶ್ಚನ್ ಅಲ್ಲಿ ಬಿ ಪಾರ್ಟ್ ಅಲ್ಲಿ 10 ಕ್ವೆಶ್ಚನ್ ಆನ್ಸರ್ ಮಾಡಬೇಕು. ಇದು ಕೆಮಿಸ್ಟ್ರಿಯಲ್ಲಿ. ಜನರಲಿ ಕೆಮಿಸ್ಟ್ರಿ ಪೇಪರ್ ಲಾಸ್ಟ್ ಇರುವುದರಿಂದ ಅದರಲ್ಲಿ ಜನರಲಿ ವಿದ್ಯಾರ್ಥಿಗಳು ಏನ್ ಮಾಡ್ತಾರೆ, ಫಿಸಿಕ್ಸ್ ಅಲ್ಲೇ ಟ್ರೈ ಮಾಡ್ತಾ ಕೆಮಿಸ್ಟ್ರಿ ಟ್ರೈ ಮಾಡ್ಲಿಕ್ಕೆ ಹೋಗುವಾಗ ತುಂಬಾ ಲೇಟ್ ಆಗಿರ್ತದೆ. ಜನರಲಿ ಕೆಮಿಸ್ಟ್ರಿ ಪೇಪರ್ಸ್ಗಳು ಈಸಿ ಇರ್ತವೆ ನೀಟಲ್ಲಿರುವಂತಹ. ಅದರಿಂದ ನಾವು ವಿದ್ಯಾರ್ಥಿಗಳಲ್ಲಿ ಮಾಡುವ ಒಂದು ರಿಕ್ವೆಸ್ಟ್ ಏನಂದ್ರೆ, ಕೆಮಿಸ್ಟ್ರಿಯನ್ನು ನೀವು ಫಸ್ಟ್ಗೆ ಅಟೆಂಪ್ಟ್ ಮಾಡಿ, ಬಯಾಲಜಿ ಅಟೆಂಪ್ಟ್ ಮಾಡಿದ ಮೇಲೆ ಕೆಮಿಸ್ಟ್ರಿ ಅಟೆಂಪ್ಟ್ ಮಾಡಿ, ಮಿಕ್ಕ ಟೈಮಲ್ಲಿ ಫಿಸಿಕ್ಸ್ ಮಾಡ್ಲಿಕ್ಕೆ ಹೋಗಿ. ಇದು ನಿಮ್ಗೆ ನಿಜವಾಗಿಯೂ ಉಪಯೋಗಕ್ಕೆ ಬೀಳ್ತದೆ. ಸಬ್ಜೆಕ್ಟ್ ಅಲ್ಲಿ ವೆಯ್ಟೇಜ್ ತೆಗೆಯುವುದಾದ್ರೆ ಇನ್ಆರ್ಗ್ಯಾನಿಕ್ಗೆ 34%, ಆರ್ಗ್ಯಾನಿಕ್ಗೆ 34%, ಫಿಸಿಕಲ್ಗೆ 32% ಇದೆ. ಇವತ್ತು ನಾನು ಮಾತಾಡುವ ಸೊಲ್ಯೂಷನ್ ಚಾಪ್ಟರ್ ಒನ್ ಆಫ್ ದ ಇಂಪಾರ್ಟೆಂಟ್ ಟಾಪಿಕ್ಸ್ ಆಫ್ ಫಿಸಿಕಲ್ ಕೆಮಿಸ್ಟ್ರಿ. ಯಾಕೆಂದ್ರೆ ಫಿಸಿಕಲ್ ಕೆಮಿಸ್ಟ್ರಿಯಲ್ಲಿ ಕೈನೆಟಿಕ್ಸ್ ಅಂತ ಒಂದು ಟಾಪಿಕ್ ಇದೆ, ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಅಂತ ಟಾಪಿಕ್ ಇದೆ, ಮತ್ತೆ ಬೇಸಿಕ್ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಅಂತ ಟಾಪಿಕ್ ಇದೆ. ಈ ಎಲ್ಲಾ ಟಾಪಿಕ್ಗಳು ಈ 32% weightage ಅಲ್ಲಿ ಇಂಪಾರ್ಟೆಂಟ್ ಟಾಪಿಕ್ ಆಗಿರ್ತವೆ. ಸೊಲ್ಯೂಷನ್ ಒನ್ ಇಂಪಾರ್ಟೆಂಟ್ ಟಾಪಿಕ್. I will be switching over to English as I go to this. What is a solution? Solution is a single phase mixture of 2 or more components. What does it mean? You will appear as one phase. Solution will appear as one phase, but it will have a mixture of 2 or more components. For example, sugar solution ಅಂತ ಹೇಳಿದ್ರೆ ಶುಗರ್ ಮತ್ತೆ ವಾಟರ್ ನೋಡುವಾಗ ನೀರಾಗಿ ಕಾಣ್ತದೆ, ಅದಕ್ಕೆ ಸೊಲ್ಯೂಷನ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಓಕೆ, we will go to the other. Next one. What is the saturated solution? Saturated solution is one in which you cannot dissolve any more solute at a given temperature. That is called saturated solution. ಅದರಿಂದ ಟೆಂಪರೇಚರ್ ಚೇಂಜ್ ಮಾಡಿದ್ರೆ ಅದರಲ್ಲಿ ಇನ್ನೂ ಡಿಸಾಲ್ವ್ ಮಾಡಬಹುದು, ಆದರೆ ಟೆಂಪರೇಚರ್ ಚೇಂಜ್ ಮಾಡದಿದ್ರೆ ಇದನ್ನು ಡಿಸಾಲ್ವ್ ಮಾಡಲಿಕ್ಕೆ ಆಗುವುದಿಲ್ಲ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಶುಗರ್ ಅನ್ನು ನೀರಿಗೆ ಹಾಕ್ತಾ ಹೋದಾಗೆ ಶುಗರ್ ಡಿಸಾಲ್ವ್ ಆಗ್ತಾ ಹೋಗ್ತದೆ. ಒಂದು ಕಂಡೀಷನ್ ಬರ್ತದೆ, ಇನ್ನು ಹಾಕಿದ ಶುಗರ್ ಅಲ್ಲೇ ಉಳಿತದೆ, ಡಿಸಾಲ್ವ್ ಆಗದೆ ಉಳಿತದೆ. ಆಗ ನಾವು ಹೇಳುವುದು ಸ್ಯಾಚುರೇಟೆಡ್ ಸೊಲ್ಯೂಷನ್. ಮುಂದೆ ಹೋಗುವ. ಪಾರ್ಟಿಕಲ್ ಸೈಜ್ ಏನಿರ್ತದೆ, ಪಾರ್ಟಿಕಲ್ ಸೈಜ್ ಡಯಾಮೀಟರ್ ನಾವು ಕೊಲಾಯ್ಡ್ಸ್ ಹೇಳ್ತೇವೆ 1 to 100 ನ್ಯಾನೋಮೀಟರ್ ಒಳಗಡೆ ಇದ್ರೆ ಕೊಲಾಯ್ಡ್ ಅಂತ. ಅದಕ್ಕಿಂತಲೂ ಕಡಿಮೆ ಡಯಾಮೀಟರ್ ಇದ್ರೆ ಆ ಪಾರ್ಟಿಕಲ್ಸ್ಗಳು ಸೊಲ್ಯೂಷನ್ ಪಾರ್ಟಿಕಲ್ ಆಗಿರ್ತವೆ. ದೇ ವಿಲ್ ಗಿವ್ ಎ ಹೋಮೋಜಿನಿಯಸ್ ಮಿಕ್ಸ್ಚರ್. ಸೊಲ್ಯೂಟ್ ಅಂಡ್ ಸಾಲ್ವೆಂಟ್. ಯಾವ ಕಾಂಪೊನೆಂಟ್ ಕಡಿಮೆ ಇದೆಯಾ ಅದಕ್ಕೆ ಸೊಲ್ಯೂಟ್ ಅಂತ ಹೇಳ್ತಾರೆ, ಯಾವ ಕಾಂಪೊನೆಂಟ್ ಜಾಸ್ತಿ ಇದೆಯಾ ಇನ್ ಸೊಲ್ಯೂಷನ್ ಅಲ್ಲಿ ಅದಕ್ಕೆ ಸಾಲ್ವೆಂಟ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಸೊಲ್ಯೂಟ್ ಅಂಡ್ ಸಾಲ್ವೆಂಟ್. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಸಾಲ್ಟ್ ಇನ್ ವಾಟರ್, ಸಾಲ್ಟ್ ಇಸ್ ಎ ಸೊಲ್ಯೂಟ್, Water is the solvent. ಇಲ್ಲಿ ನೋಡಿದ್ರೆ ನಿಮಗೆ 9 ಟೈಪ್ ನ ಸೊಲ್ಯೂಷನ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸಾಲಿಡ್ ಇನ್ ಎ ಸಾಲಿಡ್ is also a solution. Alloys, brass, German silver, bronze ಎಲ್ಲ ಕೊಟ್ಟಿದ್ದಾರೆ. Liquid solid. Liquid in a solid is a solution. Mercury in sodium, mercury with sodium. Gas in a solid, dissolved gases in minerals you can have. These are gas in a solid. Solid in a liquid, liquid in a liquid, alcohol and water. Gas in a liquid, aerated drinks. Solid in a gas, ಕೊಟ್ಟಿದ್ದಾರೆ. Liquid in a gas, water vapor. Gas in a gas, air. Air is an example for gas and gas mixture. Importance of solution. ಯಾಕೆ solution important ಅಂತ ನೋಡಿದ್ರೆ, for example, fluoride ion concentration 1 ppm ಇದ್ರೆ 1 ppm ಕೆಳಗಿದ್ರೆ tooth decay prevent ಆಗ್ತದೆ. 1.5 ppm causes teeth to become mottled, colored, and still higher concentration acts as a poison for rats. Therefore, the amount of fluoride in different concentration affect differently to the system. That is very important. Therefore, solution concentration plays a very important role. Expressing concentration. In what way you can express concentration of solution is given here. First one, percentage. When we say W by W, weight percent ಅಂತ ಹೇಳ್ತಾರೆ. Weight of the solute in 100 grams of solution. ಇದು ನೋಡಿ ಇಲ್ಲಿ 100 grams of solution ಅಂದ್ರೆ solute plus solvent. Denominator ಅಲ್ಲಿ solute plus solvent ಇರಬೇಕು, numerator ಅಲ್ಲಿ solute ಇರಬೇಕು. That is what we call it as percentage, weight by weight. ಅಥವಾ weight by volume percentage ಆಗ್ತದೆ. Weight of the solute in 100 ml of the solution. ಹಾಗೂ ಒಂದು ಉಂಟು. Solutions are two types, weight by weight percentage and weight by volume percentage. ಹೀಗೇನೆ ಲಿಕ್ವಿಡ್ಗೂ ಹಾಗೇನೆ weight by weight, weight by volume. Strength, number of grams of a solute in solution, gram per liter, gram per dm cube. ಅದು ನಮ್ಗೆ ಇಂಪಾರ್ಟೆಂಟ್ ಅಲ್ಲ. ಮುಂದೆ ಹೋಗೋಣ. Molarity. What is molarity? Number of moles dissolved in a liter. Molarity is number of moles dissolved in a liter. What is it? Moles ಅಂದ್ರೆ ಎಂತದ್ದು? Mass divided by molar mass. Moles is nothing but mass divided by molar mass. That is moles. Moles in a liter, 1000. In 1000, how much? If it is 20 ml least, 1000 is 2 ಅಂತ ತೆಗೆದ್ರೆ, in 1000 if you calculate, that is becoming molarity. Number of moles dissolved in a liter is molarity. Similarly, what is normality? Number of gram equivalent of the solute in 1 liter of solution. This is not very familiar. You may not be very familiar with gram equivalent. Gram equivalent is mass divided by equivalent mass. Mass divided by equivalent mass will give you gram equivalents. Therefore, in terms of equivalent mass, if you do, then we call it as normality. Normality is equivalent mass, in terms of equivalent mass. How do you find it? I will give you an example. Sulfuric acid, molar mass is 98. If 98 grams is dissolved in 1 liter, then it is called 1 molar solution. But when you write sulfuric acid, we write like this, H2SO4. I will show you. H2SO4. Here I have 2 hydrogen, replaceable hydrogen. Therefore, equivalent mass would be, for sulfuric acid, molar mass divided by replaceable hydrogen. Basicity we call it as 49. Therefore, if I dissolve 49 grams in 1 liter, that will become 1 normal. Therefore, 1 molar need not be equal to 1 normal. Please notice. This was 98 grams in a liter. This is 49 grams in a liter. Therefore, 1 molar is 2 normal for sulfuric acid. But it need not be always. If I take HCl, there is only 1 replaceable hydrogen. Therefore, 1 molar is equal to 1 normal. All that depends upon the number of replaceable hydrogen atoms present, normality and molarity. Molality. This is a very important concept. Molality is number of moles of a solute in 1 kg of solvent. Here, Solution is not counted. Here kg of solvent is counted. Number of moles dissolved in kg of solvent. That is called molarity. Very important concept. Parts per million, ppm. Number of mass of a solute present in 10 to the power 6 parts by mass of solution. That means if I say grams of solute present in 10 to the power 6 grams of solution. If you take, that is called ppm. It is generally used to express very low concentration. ppm, ppb, parts per million, parts per billion, they are used to express very low concentration. Mole fraction, this is an important concept. ಏನು ಮಾಡ್ತೀರಾ? Mole fraction ಅಲ್ಲಿ number of moles of one component to the total number of moles of all the components. ಎಲ್ಲ ಕಡೆ ನೀವು weight ಅನ್ನು ಮೋಲ್ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು. How do you convert weight into mole? Weight of a substance divided by its molar mass will become mole. Weight divided by molar mass will become moles. Therefore, if you say N2 is the moles of solute, N1 is the mole of solvent, N2 divided by N1 plus N2 will give you mole fraction of the solute. Similarly, mole fraction of the solvent is N1 divided by N1 plus N2. Evidently, mole fraction of solute plus mole fraction of solvent is equal to 1. Why molarity and mole fraction are preferred, or mole fraction? It should be not molarity, molality should be. Molality and mole fraction are preferred because molality and mole fraction do not depend upon temperature. They don't change. Molarity changes with temperature. It should have been L here. Molality and mole fraction are varying, do not change with temperature. Therefore, they are the terms which are used in this chapter very often. Molality and mole fraction. Relationship. For dilution, we are using the formula N1V1 is equal to N2V2. Normality of one solution, if you know, before dilution, volume before dilution, V1 is the volume before dilution, N1 is the normality before dilution, N2 is the volume normality after dilution, V2 is the volume after dilution. We can do it. If you are speaking about molarity, you can do it also. M1V1 is equal to M2V2. If you can do. These are the formula we can use. And if the basicity is different, we can, molarities are normal, basicity into molarity is normality. Basicity into molarity is normality. We can do it. If the basicities are different, if here it is, basicity is 2, here basicity is 1, then I cannot equal M1V1 is equal to M2V2. No. Then you have to multiply by basicity, because basicity of one is not the same as basicity of other. Unless it is dilution, it will be same. If it is dilution, same liquid you are diluting, same. If it is non-dilution, then these Na and Nb are different. If you are mixing two liquids, then use this formula. N1V1 plus N2V2 is equal to N3 into V1 plus V2. If the molarities are same, or basicities are same, then you can use this molarity direct only. You need not go for normality. We can do the problem even in molarity. Solid solution. Solid solution, solutions of solid in a solid. There are two solutions which both components are solid. They are called solid solution. You can see this. Steel is an alloy. Please notice this. These are all alloys, different types of alloys you can have. They are alloys are solid in a solid. Brass, bronze, we were saying, German silver, they are all coming under this category. Solid solution types. Here it is given. Two types are there, in which atoms, ions, or molecules of one substance take the place of other substance in the crystal lattice. Those who have studied the solid chapter, we understand that metal ions are occupying lattice positions, and one ion is replaced by other in the lattice position, then it is one type of substitutional solid solution. Another one is the smaller atoms can go and occupy, smaller atoms like hydrogen, nitrogen, carbon, these atoms can go and occupy the interstitial position, then they are called interstitial solid solutions also. Tungsten carbide is an example for interstitial solid solution. We are speaking about solutions of solids in liquids. What are these? You take any salt, if it is soluble in water, you can prepare a solution in water. The ionic solids dissolve in water because water is a polar solvent. Ionic solid dissolve in polar solvent. Whereas non-ionic solid, if I want to dissolve iodine in water, it doesn't dissolve. Iodine does not dissolve in water. Iodine better dissolves in benzene. Iodine dissolves in carbon tetrachloride. There is a provision because non-polar solutes dissolve in non-polar solvent. Polar solutes dissolve in polar solvent, or ionic solids dissolve in ionic solvents or polar solvents. This is what you have to say. Like dissolves like, unlike does not dissolve unlike, that we can say. Sugar dissolves in water because of hydrogen bonding. Sugar can form hydrogen bonding with water. That is why sugar dissolves in water. This is about saturated, unsaturated, supersaturated. Here, more solute can be dissolved. Here, no more solute can be dissolved. We have forcefully dissolved more solute by increasing the temperature and then allow it to cool. Then it is becoming supersaturated. It is more than its content, it is saturated, then it is called supersaturated solution. Solubility of solid in liquid. What is the word solubility mean? Solubility means how much amount of solute dissolved in a given amount of liquid. Maximum amount of solute that is dissolved in a given amount of liquid is called solubility. Beyond that, you can't dissolve. That means I can say it is the concentration in a saturated solution. Concentration of the liquid or the solution in a saturated solution is called solubility, beyond which you cannot dissolve. That is the meaning of solubility. Solubility in terms of lattice energy and hydration energy. This should be known. Why sodium chloride dissolves more in water? Why silver chloride does not dissolve in water? I will put this question. Let me put. Sodium chloride dissolves more in water, whereas silver chloride dissolves very less in water, sparingly soluble. This is highly soluble. Why? The reason is there are two concepts. One is called lattice energy. Another one is called hydration enthalpy or energy. If lattice energy is less, hydration energy is more, then it is soluble. If lattice energy is more and hydration enthalpy is less, then automatically it is insoluble. Therefore, it all depends upon relationship between lattice energy and hydration enthalpy. Higher the hydration enthalpy, higher will be the solubility. More will be the solubility. For an ionic solid, this relationship holds good. Hydration energy should be more, lattice energy should be less. Effect of temperature on solubility. What do you think? If the temperature is increased, solubility increases or decreases? It could increase or decrease depending upon whether the solution dissolution is exothermic or endothermic. Very important. Don't be under the impression that if you put a solute and increase the temperature, solubility always increases. Need not be. Solubility may either increase or decrease according to Le-Chatelier's principle. You must have studied this Le-Chatelier's principle under equilibrium chapter, which very clearly says it favors high temperature favors exothermic reaction, endothermic reaction, and low temperature favors exothermic reaction, which is illustrated here. If you take sodium nitrate, potassium nitrate, sodium chloride, KCl, etc., if you add more temperature, more will dissolve because dissolution is endothermic. If it is endothermic, reaction is favored at high temperature. See, I have put an arrow here. That means solubility increases with increase in temperature. But let us look for some other options. Lithium carbonate, sodium carbonate, cesium sulfate, if you take, their solubility dissolution is exothermic. If it is exothermic, it is favored at low temperature. Therefore, as the temperature increases, solubility decreases. Solubility decreases with increase in temperature. for these salts. Therefore, don't be under the impression that it's always solubility increases with increase in temperature. Is not true. Solubility may increase or decrease depending upon whether the reaction is exothermic or endothermic. Coming to solutions of gases in liquids, solubility of a gas in a liquid. Yes, it is defined as the volume of a gas in cubic centimeter that can dissolve in a unit volume of liquid to a saturated solution at a temperature of the experiment under atmospheric pressure. What is it? Solubility of a gas means how much gas will be dissolved in mole per liter. We can express in terms of mole per liter. How many moles of a gas can be dissolved in a liquid? That can be expressed in mole per liter. Nature of gases. Let us look for this. This is the important question which can be asked. If there are hydrogen, oxygen, nitrogen, they dissolve in water to a very small extent. Whereas these are gases which are difficult to liquefy. Hydrogen, helium, oxygen, nitrogen are the gases difficult to liquefy. They will be dissolved less. Whereas ammonia, carbon dioxide, HCl, H2S are highly soluble. They are dissolved more. Therefore, gases which are easily liquefiable are dissolved more. Gases which are difficult to liquefy are absorbed less. I can explain also here. Oxygen, the liquefaction temperature is minus 183 degrees. Nitrogen, minus 196. Whereas ammonia is minus 33. HCl is a gas which can be easily dissolved. H2S is a gas which can be easily dissolved. Carbon dioxide is also gas which can be dissolved but under pressure. Okay. Hendrickson law. This is a very important concept. I will only stress upon this. Solubility of a gas in a given volume of a liquid at a particular temperature is directly proportional to pressure of the gas above the liquid. What does it mean? If you apply more pressure, more gas will be soluble. More is the pressure, more is the gas soluble. Remember that one. At a given temperature. More is the applied pressure, more gas will dissolve. Soda water, you understand? In soda water, if the applied pressure is more carbon dioxide dissolves. This is what we can say. But mathematically, always remember this. This is the formula you have to remember to work out problems. The partial pressure is equal to Hendrickson constant into mole fraction. Mole fraction in the solution. Therefore, higher the Hendrickson constant, lower is the mole fraction. Therefore, please remember, higher the Hendrickson constant, lower is the solubility of the gas. Lower is the solubility of a gas. Therefore, remember this, Pa is equal to Kh into Xe. Slope and other things are given, not important. But remember, if you plot a graph of Pa versus Xe, there should be a slope called Kh. Kh is called slope of the line because Y is equal to Mx. I will write here, Pa is equal to Kh into Xa. If you write, is nothing but Y is equal to Mx. Y is equal to Mx. That line should pass through the origin actually. You should have the line passing through origin. It doesn't show like that. This is the graph. It should pass through origin because any of the graph of Y is equal to Mx should pass through the origin. Kh is a function of the gas. It depends only on the gas. Okay. Application of Hendrickson law. In carbonated beverages like soda, when you open the bottle, more carbon dioxide escapes out. Solubility decreases and the gas bubbles out. This you know. Even if you add little sugar to soda, water, more bubbles are seen out. The carbon dioxide escapes out. When sugar dissolves, carbon dioxide is pushed out. That you can see. Deep sea diving, compressed air cylinders do contain nitrogen and oxygen. Oxygen is required for breathing and purpose. And nitrogen being heavier gas, just like oxygen, nitrogen is 28, oxygen is 32. When you come to the surface, what would happen is nitrogen will escape through the veins and capillaries causing a problem, a pain. It causes, it's called bend. To avoid this bend, what they do is they replace this nitrogen by helium. Helium being lighter gas, solubility of that helium in blood is less. Therefore, as you come to the surface, you will not experience that pain. Therefore, in air, helium is replacing the nitrogen in deep sea diving. Function of lungs. In lungs, the partial pressure of oxygen is high. It combines with hemoglobin to give oxyhemoglobin. In the tissues, what would happen if the working tissues or working muscles, oxygen level is less. Therefore, oxygen is released from oxyhemoglobin to myoglobin and then going for the functions of the cell. That is how it goes. Myoglobin has affinity at lower pressure and hemoglobin has oxygen affinity at higher pressure. Therefore, that is how hemoglobin transfers oxygen from oxyhemoglobin to myoglobin. For climbers, people living in high altitude, level of oxygen is less. When the level of oxygen is less, you cannot think properly, feel weak, unable to think clearly. This is called anoxia. Therefore, this is, before I go into ideal and not ideal solution, I would like to tell you that please remember PA is equal to KH into XA. This you do not forget. This is a very important, which is called Hendrickson law. Next, we move on to ideal and non-ideal solutions to liquids. What is an ideal solution? If I mix A with B, if there is no loss of volume, then it is called ideal solution. What does it mean? 100 ml of A is mixed with 100 ml of B. Total volume becomes exactly 200. Then it is called ideal. And there is no neither heating nor cooling takes place during mixing. Delta H mixing is 0. Then it is ideal. Ideal solution is one which volume of mixing is 0. Volume change during mixing is 0. Enthalpy change during mixing is also 0. Raoult law. Vapor pressure. An ideal solution is one where each component of the solution, two liquids, okay? Both the liquids, solute and solvent, obey Raoult law. What is Raoult law? Vapor pressure of any component is equal to vapor pressure of each component is equal to mole fraction of that component into vapor pressure of the pure component, 100% pure component. This is called Raoult law. Vapor pressure of any component in a mixture is the product of two things, mole fraction and vapor pressure of the pure component, which is given here in this formula here. This is next. Ideal solution. If both the components obey ideal gas equation, then it is called ideal solution. Raoult's law. Total vapor pressure is the sum of PA plus PB. That will be same. Some examples of ideal solutions are benzene and toluene. How do you say they are ideal? Because their structures are identical. This is homologous series member. Benzene, 1 CH2 extra, CH3, toluene. Hexane, 1 CH2 extra, heptane. Ethyl bromide, ethyl iodide. Only bromide is replaced by iodide. Bromobenzene is replaced by chlorobenzene. These are considered to be almost ideal solution. These are examples for ideal solution. Non-ideal solution. Non-ideal solutions are of two types. If delta V mixing is not 0, delta H mixing is not 0, such solutions do not obey Raoult's law. Total pressure is not the sum of the two. PA is not equal to this. PB is not equal to this. Therefore, P is not equal to PA plus PB. That we can understand. Then it is called non-ideal solution. Solution showing positive deviation from Raoult's law. What does it mean? When you mix A and B, if A and B repel each other, the molecules of A and B repel each other, what would happen? The total pressure of A will be greater than the product. So vapor pressure of B will be also greater than product. And total pressure is also greater than this. It will be higher. Higher will be the total pressure. For example, ethanol and water is one example. Methanol and water another example. Ethanol acetone, benzene acetone are examples for one showing positive deviation from Raoult law, because both the components repel each other more than the components of the molecules of each component molecules. They repel less, and when they mix with A and B, they repel more. Delta V mixing is positive. What does it mean? If you take 100 ml of A plus 100 ml of B, 100 ml of ethanol and 100 ml of water, total volume may be 200.1, 200.2, something little more than the 2. 100 plus 100 is not 200. 200 plus something, that is called delta V mixing. Similarly, when you mix the two, what happens is there is delta H mixing is positive. Delta H is positive means endothermic reaction, therefore cooling takes place. Therefore, ethanol water temperature becomes little less than both ethanol and water when you mix the two. It is cooling that is observed when you mix the two. Types of non-ideal solution, one showing negative deviation from Raoult's law also will be observed. Here, there is attraction between A and B. When there is attraction between A and B, vapor pressure becomes less. Vapor pressure of B is also less. The total vapor pressure is also less than PA plus PB. You can observe it in HCl water, chloroform acetone, acetone aniline, HNO3 water, chloroform benzene. These are those. When you mix, delta V mixing is negative. What does it mean? 100 plus 100 of the two, HCl and water, if I mix, the total volume may be 199.2, 99.6. It will not be 200. And delta H mixing is negative, means heating is observed, exothermic reaction that is observed. Therefore, one showing negative deviation, one showing positive deviation, one does not have any deviation. That is called ideal solution. Therefore, what is an ideal solution? Ideal solution is one in which all the components of a mixture behave or follow Raoult's law. Follow Raoult's law. That is better. This is the last part, colligative properties. What is a colligative property? A property which depends on the size of the particle, not size, shape, no, only number. One which depends upon the number of particles present in the solution are called colligative property. There are four: osmotic pressure, freezing point depression, elevation in boiling point, and vapor pressure. Relative lowering of vapor pressure. These are the four. Relative lowering of vapor pressure, osmotic pressure, freezing point, depression, and boiling point elevation. We'll check. What is osmotic pressure? What will happen? What is osmosis? See here you have a solution. Here you have a solvent. Let us say what would happen is solvent molecule through a semi-permeable membrane. This is a semi-permeable membrane. Through the semi-permeable membrane, solvent molecules move from lower concentration of the solute to the higher concentration solute. They will just move across the semi-permeable membrane. Here volume increases. You have seen that volume increases. Now what you have to do is you apply an external pressure here so that volume remains the same before osmosis. Just to prevent osmosis, what is the pressure required? It's called osmotic pressure. Osmotic pressure is denoted by the expression pi. Pi is the notation that is used for osmotic pressure. Van 't Hoff-Boyle's law. Just Boyle's law is modified by Van 't Hoff and it's called as Van 't Hoff-Boyle's law. What Van 't Hoff-Boyle's law says? Van 't Hoff-Boyle's law says very clearly, mathematically I can say, at constant temperature, osmotic pressure of a dilute solution, always applicable for dilute solution, osmotic pressure is directly proportional to concentration. And the concentration increases, osmotic pressure increases, but it's applicable only for dilute solution. Therefore, I can say pi is proportional to 1 by V because concentration can be given as 1 by V, inversely proportional to volume. Therefore, pi V is a constant. We know that. PV is a constant just like that. Pi V is also a constant. Van 't Hoff-Charles law. Van 't Hoff-Charles law speaks about at constant concentration, osmotic pressure is directly proportional to absolute temperature. This is called Charles law at constant concentration. Avogadro's law says equal volumes of any two gases exerting the same osmotic pressure should contain equal number of molecules. Pi 1 is proportional to N1, pi is proportional to N2. If pi 1 is equal to pi 2, N1 is equal to N2. That is what. Combined solution equation is pi V is equal to nRT. Pi V is equal to nRT is called combined solution equation. Therefore, N is equal to W by M. Therefore, please remember M is equal to WRT by pi V. Remember this. I repeat again, pi V, sorry, here we write, pi V is equal to W by M RT. You can put this V here, automatically we get that expression. Pi is equal to WRT by MV. M, if you shift here, pi will come here. Yes. Isotonic solution. What is the meaning of isotonic solution? A solution having same osmotic pressure is called isotonic solution. If two solutions exhibit same osmotic pressure, they are isotonic. Generally, if there are no ionic solids are involved, then their concentrations are equal. W1 by M1, number of moles, W1 by M1 should be equal to W2 by M2. Therefore, if you put W2 here, M1 by M2, same thing here. The concentration of the first is equal to concentration of the second. C1 is equal to C2, then they are called isotonic solution, provided there are no ionic solids here, molecular solids only. Isotonic solutions, we can say W1 by M1 V1 is equal to W2 by M2 V2. This you can say. You can pi total is equal to C1 RT and C2 RT. You can add. This also is possible. Percentage of glucose solution isotonic with 1.5% urea. What is the meaning of 1.5%? Meaning what? 1.5 grams in 100 ml of water. That is the meaning 1.5. 1.5 divided by urea mass is 60 should be equal to what is X glucose weight by molar mass 180. X will be 4.5. We can find out. That will give you the first isotonic solution. Isotonic weight W1 by M1 is equal to W2 by M2. This formula you can use and substitute. I repeat again, W1 by M1 is equal to W2 by M2. Here I will write W1 by M1 should be equal to W2 by M2. This is the formula you can use for working out problems in isotonic solution. Relative lowering of vapor pressure. P0 is the vapor pressure of the pure solvent. P is the vapor pressure of the solution. When a solute is added to the solution, vapor pressure decreases. Divided by vapor pressure of the pure solvent is called relative lowering of vapor pressure. This is called relative lowering of vapor pressure. And relative lowering of vapor pressure, Raoult's law. See here, there is another Raoult's law for relative lowering of vapor pressure for a non-volatile solute is equal to mole fraction of the non-volatile solute in the solution. Mole fraction of the non-volatile solute in the solution. Relative lowering of vapor pressure is equal to mole fraction of the non-volatile solute in the solution. It is applicable only when the solute is non-volatile. If the solute is volatile, this is not applicable. Limitation. When can I apply Raoult's law? When can I limit this application? Only dilute solution is applicable. Applicable solute should be non-volatile, I have said. Solute should neither undergo association nor dissociation. This is the third condition. Elevation in boiling. I would like to tell you a few things. When a solute is added to the solvent, what will happen? Vapor pressure decreases. If the vapor pressure decreases, boiling point increases. Please remember, vapor pressure decreases, boiling point increases. Therefore, there will be elevation in boiling point. And elevation in boiling point is directly proportional to molality. You can put a constant called Kb. Kb is called molar elevation constant or ebullioscopic constant. Molar elevation constant or ebullioscopic constant. Therefore, remember delta Tb is equal to Kb into m. Or I can even remember delta Tb is equal to 1000 Tb W2 divided by W1 M2. Because the whole thing will give you molality. Molality will be 1000 W2 divided by W1 M2. That is molarity. Kb will be already there. Elevation in boiling point. Elevation in boiling point we have given here. You can find molar mass by using this formula. Same formula. I have taken delta Tb here. This is delta Tb. Difference in the boiling point of the solution and boiling point of the pure solvent is called delta Tb. W1, W2, Kb 1000 will give you molar mass. Molar mass or molecular mass. Kb value for water you by heart 0.52 and that benzene is 2.53. Depression in freezing. What will happen when a solute is added to the solvent? Freezing point decreases. That is why salt is added to ice. When salt is added to ice, the freezing point of ice decreases. It melts. Therefore, you can lower the freezing point by keeping ice salt mixture. You can lower the freezing point. Therefore, delta T is equal to Kf into m, where Kf is called molar depression constant or cryoscopic constant and molarity. Same formula. Same. Only Kf here, there it was Kb. Depression in freezing point almost same. The value is, remember, Kf is 1.86 for benzene, water, and benzene is 5.12. Van't-Hoff factor. What is Van't-Hoff factor? If a solute is dissociate or associate, then there is a factor called Van't-Hoff factor I. Van't-Hoff introduced this factor which is called Van't-Hoff factor. If there is dissociation, number of particles will increase, quantity increases, colligative property increases, therefore I is greater than 1. If there is association, what does it association mean? Two particles become one. Association means number of particles in the solution decreases, Van't-Hoff factor is less than 1. Van't-Hoff factor more than 1, Van't-Hoff factor less than 1. Remember, for dissociation and association. What is Van't-Hoff factor given here? Observed colligative property divided by theoretical colligative property. When I say theoretical colligative property, no association, no dissociation. Considering the particle as one, substance will not either associate or dissociate this one. This is the observed one is because of association or dissociation. If I is equal to 1, what does it mean? There is neither dissociation nor association. If I is greater than 1, that means it is dissociation. If I is less than 1, then it is called association. In terms of molar mass, I can do molar mass, normal molar mass divided by observed molar. Observed molar mass comes down, theoretical molar mass goes up. Van't-Hoff factor. Van't-Hoff factor I. Calculation done. I is equal to 1 plus n minus 1 into alpha by 1, something like this. Please remember, I is equal to alpha is equal to, there is a mistake here. Make it alpha, you replace and make it I minus 1 by n minus 1. This formula can be applied. Remember this formula. This is for dissociation. Dissociation alpha is equal to, degree of dissociation is equal to I minus 1 divided by n minus 1. N is the number of particles formed, either 2, 3, 4, etc. This is how you can work. In case of association, what would happen? Remember this formula. Alpha is equal to I minus 1 by 1 minus n minus 1, because here association takes place. 2 become 1. Therefore, n is 2 means half it will become. Number of particles become half. That is how it goes. Therefore, alpha, degree of dissociation, is calculated by the formula I minus 1 divided by 1 minus n minus 1. Yes. As I said, I have completed the synopsis part of it, including Van top factor, I calculation, everything. Now we will look into the questions which are coming under this topic. Few questions I will take. Question 1. The vapor pressure of two liquids P and Q are 80 and 60 torr respectively. What is the meaning of torr? Torr is nothing but mm of mercury. It is given as mm of mercury. Torr is nothing but mm of mercury. Okay. The total vapor pressure of the solution is obtained by mixing 3 moles of P and 2 moles of Q. What do you have to do? There are 3 moles and 2 moles. Find out mole fraction of P and mole fraction of Q. How do I find mole fraction of P? NP is equal to number of moles of P divided by total number of moles of P and Q, 5. Similarly, number of moles of Q will be 2 by. What you have to do is total pressure should be number of moles, mole fraction into the vapor pressure of the pure component, 80, plus number of moles into vapor pressure of pure Q. Pure Q is 6. If you work out like this, you will get the answer. This comes to 48 and this comes to 24. Therefore, answer must be 72. Answer will be 72 torr, D. D is an answer. Therefore, did you get now? Please remember the total pressure in a mixture. You will take it as an ideal. If it is total pressure in a mixture, I will put it. If it is ideal solution, total pressure, we'll write this way, is mole fraction. Mole fraction, I will write N1 into P naught 1 plus N2 into P naught 2. This formula you remember. N1 is the number of moles. Sorry, don't write N1. You write it X1. Here you write X2. Not moles. You have to take number mole fraction, where X1 is the mole fraction of 1 and X2 is the mole fraction of the second. X1 into P1 naught plus X2 into P naught 2. That will give you total pressure. We'll take the second question. Answer is given. All that is over. I worked out and explained also. Question 2. A solution of urea boils at 100.18 degree at the atmospheric pressure. What is the boiling point of pure water? 100 degree. Therefore, what is delta TB? If you write, I will do it here, lower part. Delta TB will be equal to 100.18 minus boiling point of water, 100. You can do it in Kelvin also, but difference will be the same. 0.18. Difference in temperature would be the same in Kelvin and degree centigrade, 0.18. Therefore, what you do now is this. Delta TB by KB is equal to delta TF by KF. This formula you use. Delta TB by KB is equal to delta TF by KF. You are finding out at what temperature it will freeze here. At what temperature it will freeze. Therefore, what is the delta TB? 0.18. What is KB? KB is given 0.512. Is equal. Delta TF you are finding out. KF you know 1.86. Can't you calculate delta TF? By this, if you calculate delta TF, this will come to 0.654. Now, don't take 0.654 C as an answer. What is the question? What is the freezing point of the solution? Solution will be lower than that of the solvent. Solvent, what is the freezing point? 0 degree. It will be less than 0 degree. Difference is only 0.654. Delta will be delta. What is the freezing point of the solution is below 0 degree. Therefore, answer must be minus 0.654. Therefore, see the question before you answer. If it is difference, if it is asked, what is the depression in freezing point if they ask you 0.654? What is the freezing point of the solution if you ask it minus 0.654? Therefore, at what temperature it will freeze is minus 0.654. What is the depression in freezing point? Answer would be C. For this question, answer is D. Same thing is answered and given here. Third one. A solution of acetone in ethanol. This was given. In our explanation, it was there. Acetone and ethanol is one which shows positive deviation from Raoult law. Therefore, all those examples are to be known to you to answer this question. Acetone and ethanol is one which shows positive deviation from Raoult law. Ethanol and water shows, methanol and water shows. Therefore, this also shows positive deviation from Raoult law. Nothing more than that. Fourth, 3D, okay? 0.5 molar solution of a weak acid is 20% ionized. Weak acid is HX. In this question. HX is the weak acid. I will answer here. HX. How many ions it gives? H plus plus X minus. Please remember. Since this is the one which gives it, alpha is 20%. 20% is ionized. Alpha is 0.2. Can't you calculate I? What is the formula I had? I gave you alpha is equal to I minus 1 divided by N minus 1. Yes. Alpha is 0.2. Keep it. I do not know I. I want to calculate by 1. N is the number of ions it produces. How many? 2. 2 minus 1. You use it. 2 minus 1 is 1. 1 into 0.2 is 0.2. Therefore, I is 1.2. Simple. Therefore, in such a simple things, what you can do is 20% means 1.2. You can directly write. You need not do all that. For 2 ions, if it is forming, I is 1 plus alpha. I is 1 plus alpha, 1.2. If you find 1.2 as I, if Kf water is this one, the lowering of freezing point of the solution is, see this. Remember this, delta T F is equal to, whenever there is association, dissociation, use I into Kf into M. Otherwise, Kf into M only. If there is I is 1, then it is Kf into M. If there is association or dissociation is there, I into Kf into M. What is I here? 1.2. What is Kf here? 1.86. What is molality here? 0.5. Can't you multiply? All can be multiplied. If you multiply all as it is shown here, it will become 1.12. Answer will become 1.12 Kelvin. Degree centigrade and Kelvin is one and the same. Difference in temperature can be degree centigrade or Kelvin. Now, lowering in freezing point, delta T up only. Therefore, it is a positive value. What is the freezing point if it is that? Minus 1.12. Lowering of vapor pressure or freezing point is 1.12 Kelvin. Answer is D. That is D. You can make out whatever that is done. Question 5. 0.02 molar aqueous solution of an ionic compound freezes at this temperature. Number of moles of ions which 1 mole of ionic compound produces in water will be. Just actually, it is much easier. I can tell you the answer by looking at the formula of the compound. Cobalt, NH3, NO2, and Cl if you take. It will give only 2 ions. One is the complex ion, cobalt, NH3, NO2, and this is plus Cl minus. Only 2 ions it will produce. If it produces 2, answer would be this. Whether it is so, how do I check that is a question. What is the method by which you can do it? You can do it, if you want mathematically do it this way. Delta TF is equal to I into KF into M. This is the formula which I gave you earlier. Find out I. I will come very close to 2. That means answer is 2. You substitute, I will be 1.97 it will become, which is very close to 2. Therefore, answer is 2. This is one way of doing it. Another way of doing it is look at the formula, get the ion. If the ions are 2, I is 2. That's done. Question 6. The freezing point depression constant of water is 1.86 kg per mole. If 5 grams of sodium sulfate is dissolved in 45 grams of water, the freezing point is changed by minus 3.82 degree. Calculate the Van't-Hoff factor of sodium sulfate. When I say Van't-Hoff factor to be calculated, remember this formula again and again that has come. Delta TF is equal to I into KF into M. Simple. You are supposed to calculate I. How do I calculate I? I is equal to delta TF divided by KF into M. How do you find molality? The question. Delta TF you can calculate. TF is given here 1.86 given. Sorry, delta TF is 3.82, no? Delta TF is 3.82. KF is 1.86. 3.82 divided by 1.86. What is molality? How do you find molality is the question. 5 grams of sodium sulfate is dissolved in 45 grams of water. 5 grams sodium sulfate, 45. In 1000 grams of water, how much dissolved? That one will give you number of grams in water. Now, once we get that, 5 into 1000 divided by 45 is the weight. Divided by, what is the molar mass of sodium sulfate? Sodium is 23. 23 into 2, 46. Sulfur is 32. Oxygen is 16 into 4, 64. Add this, will come to 111.142. It becomes, I think, 142. 142. Molar mass is 142. This is my molality. Molality. Therefore, substitute these values, you will get this. I is equal to delta TF. Let me take up 1.86 divided by 1.86. No. Delta TF 3.82. 1.86 into M. M, you have to write M value 5 into 1000, 45 into 142. If you work it out, the answer will be 2.63. You can easily get it. Answer is this. Like that, you have to work out the problems. Last one we'll do, 7th one, and then I will give 1 or 2 minutes for you to ask any question. Last question will take. 200 ml of aqueous solution of a protein contains 1.26. Osmotic pressure of the solution at 300 Kelvin is found to be this much. Molar mass of the protein will be. What is the relationship between molar mass and osmotic pressure? By heart, this formula. Pi is equal to WRT by MV. Remember, automatically you can answer. W is what? W is the weight of the solute. Where is it? 1.26 grams. What is R? R they have given in the problem. No need. 0.083. Temperature is also given 300. Divided by. What is molar mass they have asked? In place of molar mass, you keep it here. Pi you write here. Pi is 2.57 into 10 to the power minus 3 into V. V should be in liters. Please remember, Here, your unit should be, unit of R is liter. Therefore, the 200 ml should be written as liter. That will be 0.2. 0.2. 200 ml become 0.2. You will get molar mass. This answer will be 61038 gram per liter. Answer is D. Yes. Dear students, we have already done 7 such questions so far. We do not have any more time. Almost my time is up. I'm giving 1 or 2 minutes for you to interact with me and ask any question, anything you would like to ask on this topic. I have given maybe 16 questions. In the material, I will give you the synopsis and those 16 questions with their answers also I shall provide you. I will send to KSTA and it will be given to you. If you have any specific questions, you can ask me now.
Dr. Richards,
Yes.
this was a very useful talk for the students. You have really clearly explained various aspects concerning the solution, solid, liquid, liquid gas, variety of things. Very, very useful along with the examples. Definitely students are really well educated. And sometimes students, sometimes they ask, this colloidal, mixture, where does it fit in and all that?
Yeah. There is a topic, colloids itself as a topic, surface chemistry is a separate topic which is discussed. There you are having colloids are in between that of suspensions and solutions. Solutions, if I take, let us say, sugar, you know it. I'm just telling you for the benefit of the students. Yeah,
Students.
If I take sugar solution, little of sugar, put it in water and dissolve, it looks like water only. It looks a homogeneous. Whereas colloid, you feel that something is there. You may not be, if you filter through the filter paper also, it will filter. It will not get separated. That is what we colloid is. If it is suspension, you are able to separate a precipitate and the supernatant liquid through a filter paper. The pores of the filter paper, if they passes through, but if it looks like something is there, but you are not able to separate by ordinary filtration, then it is colloid. That I can say that way. Yes, sir.
Thank you very much, sir. It's a
Thank
wonderful
you.
session.
Thank you. Thank you very much for the opportunity that is given to me.
Thank you,
Yes.
sir.
Yes, sir.
Now I request our honorable member Ambekar Eknath sir if anything to say or any questions. Dr. Eknath sir. Yes, sir.
Yes, yes. I'm just trying to see my video, audio. Hello?
Yes,
Yes,
sir.
sir.
Please.
I'm sorry. I went back in time in 1970 when I took physical chemistry and other things. So, but the way you explained things, I really enjoyed it very much. And it was very well explained. I envy the students of the day for a good lecturer
Yes.
like you. Thank you very much, sir. Very much enjoyable. Thank you.
Thank you, sir. Thank you very much. Yes.
Thank you very much, sir. As of now, there are no questions from the students. We'll get back to you once they will send offline or through
Okay.
mail.
Okay, sir. Sure.
So
Thank you.
at the
Thank you very
outset,
much
I
for
would
the
like-
opportunity that is given to
Thank
me.
you, sir. Thank you, sir.
Yes, sir.
I
Thank
would
you.
like to conclude formally with the vote of thanks, sir.
Yes.
At the outset, I would like to thank Professor Richard Gonsalvis, sir, for accepting our invitation to deliver this session on solutions in this talent search webinar series. Thank you very much, sir, on behalf of all the KSTA and on behalf of all the academy members and on behalf of all the participants. Once again, thank you very much, sir. Thank you. Also, I would like to thank our chairman, sir, Professor S. Ayappan, sir, and our honorable members today who have joined with us
Professor Basuraj Mulimani sir, Professor Ambekar Eknath sir, for guiding us throughout these webinar program series continuously and encouraging us to take this event successfully and make this outreach to all the needy students and teachers. Thank you very much, sir.
Thank you, Mesh. Thank you.
Also, I would like to thank our CEO, Dr. M. Ramesh sir, and our academy staff, Senior Scientific Officer, Dr. Anandar, Shri V.K. Srinivasu, technical people, Shri Lobo, and Shri Siddegowda, and non-technical people also, who have been guiding us in this webinar series program. Last but not least, I would like to thank all the participants, students, TU students, and teachers. Apart from that, general public who are also science aspirants, who are here with us in this Cisco WebEx platform, as well as YouTube platform. On behalf of KST and on behalf of myself, I wholeheartedly thank you. And I request all the participants to ask the questions. ಪ್ರಶ್ನಿಸದೆ ಏನನ್ನು ಒಪ್ಪಬೇಡಿ ಅಂತ ನಮ್ಮ ಶ್ರೀ H.N. ನರಸಿಂಹಯ್ಯನವರು ಹೇಳ್ಬಿಟ್ಟಿದ್ದಾರೆ. ಅದೇ ತರ ನೀವು ಪ್ರಶ್ನೆಗಳನ್ನ ಕೇಳಬೇಕು. ಪ್ರಶ್ನೆಗಳನ್ನ ಕೇಳಿದಾಗ ನಿಮ್ಗೆ ಇನ್ನೂ ವಿಷಯದ ಬಗ್ಗೆ ಸರಳವಾಗಿ ತಿಳ್ಕೊಳ್ಳುವಂತ ಒಂದು ಹಿಡಿತ ಸಿಕ್ಬಿಡುತ್ತೆ. ಅವಾಗ ವಿಲ್ ಬಿ ಏಬಲ್ ಟು ಗೆಟ್ ಗುಡ್ ಸ್ಕೋರ್ಸ್ and know the fundamentals of the subject. With this, I would like to thank one and all. Thank you very much, sir.
Thank you.
Thank you.
Thank you.
I request participants to follow Academy, social media, and website for upcoming program details. We'll be updating regularly. Thank you very much, sir. Thank you, Richard, sir, once again.